On to Chapter 6, Section 1. We're now going to work with rational expressions and functions, where we will be multiplying and dividing. Now, we need to know, first of all, what is a rational expression? And a synonym for this is primarily a fraction. This is a rational expression. And this, and this, and this, as we'll see throughout Chapter 6. So they're sort of fractions, but not just simple fractions. We're getting letters in the numerator and denominator, and we'll look how to work with them. So we're going to simplify these rational expressions. We're going to multiply and simplify. We're going to divide and simplify. And we're also going to look at a special term that we'll use somewhat in later sections, the vertical asymptotes. Okay, so let's get started. Here we have a fraction, and we want to find when we replace the x's with the value 8 first, and then later the value -4, what these become. So let's start off slowly, and we'll just set it up right over here. So it's going to be 2 times 8 plus 6 all over 8 plus 4. So 2 times 8 is 16. This is going to be plus 6 is 22 over 12. And now we want to simplify. We know we can take a 2 out of here and get 11, and a 2 out of here and get 6. So this value then would be 11/6. And I'm going to need room. Well, I guess I can work here. So 2 times -4 plus 6 divided by -4. I didn't need parentheses there. Plus 4. Now, when you get something like this in the denominator, you're going to get a 0 in the denominator. So it really doesn't make any difference what you get in the numerator, because anytime you end up with a 0 in the denominator, this value here with a 0 in the denominator will be undefined. We could do the top. That's going to be a -8 plus 6 is going to be a -2. But again, once you get the 0 in the denominator, this value is undefined. Now we've done these before where we are asked to find the domain of the function. And basically it's just to equate the denominator to a 0. And now we'll factor that denominator. Sort of like finding the zeros. X, 2, 6. Factors of 12 that when we add them together give us an 8. But this is negative, this is positive. So both of these need to be negative. So we're going to equate now each of these to 0 using the principle of the zero product that we mentioned before. And this just transposes. We get x equals 6 or x equals 2. Now, these are values that in the denominator over here will make your denominator a 0. So when you are defining the domain, it will read in set builder notation, x is such that x is all real numbers, but x cannot be 6 or 2. These are your qualifiers. Again, domain could be any x value, but cannot be a -6 because that would make this a 0. I'm sorry, a 6 or a 2. All right. Now in number 2, we're asked to simplify each rational expression. And in simplifying, we're asked to take out common factors. So what do we need to do here? Well, basically the technique is to take out the factors of 36. And let me set this up for you. Now, eventually you're going to do this in your head, but to show you the technique, we take the number 36 and we get the prime factors. So our 36 is actually 2 times 2 times 3 times 3. That's 36. And our 20 is 2 times 2 times 5. And then keep in mind we also have x, x, and we have y, 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 y. I'm oversimplifying just to show you this one time what it's like. And then here we have y, 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 y. Okay. Now when we go to take out ones here, 2 over 2 is a 1, so we can cancel that out. 2 over 2 is a 1, we can cancel that out. So in a sense, this was a 4. We can take a 4 out of that, and that gives us a 9. Take a 4 out of that, and that gives us a 5. So that's what we have here, 9/5. And then we're taking out ones here. This is a 1. This is a 1. Y over y is 1. So we're left in our numerator with an x and our denominator with a y. Now, we could have figured that out by using a technique earlier of bringing the 1 up, subtracting it from the 2. That gives us the x. And bringing the 4 down, subtracting it from the 5. And that leaves me with a y. Again, many of you will be doing this mentally, but I wanted to show you, again, the technique that might be involved as background to cancel out the ones. Now, when you get to something like letter B here, since they are trinomials, how do we factor that or find out what a common factor of 1 might be? And the answer is we do factor it. So we can't take anything out of the top, but we can put 2 sets of parentheses like so. So this is where our work from chapter 5 comes in. This will be A and A. This is going to be 3 and 2. and our 3 needs to be negative, our 2 positive. And again, we FOIL to see that we get this. And then we go A and A. Now here we're going to have a 6 and a 3. And they're both going to be negative. Now that we've factored these, we look to see if we have 1s anywhere. Well, anything divided by itself is 1. So this cancels out. And our answer then is this. Okay? Now, for these, they want us to write each function in simplified form and then list all restrictions on the domain. So, let's work on the first one. Our top is going to be t minus 4. And our bottom, we can't take anything out, so we're going to just factor it. And it'll be t and t. And this is going to be 4 and 2. And this 4 will need to be negative, and this will be positive. Now, a technique might be you put this in parentheses and put a 1 up there. Remember, you can take a 1 out of anything, except 0. Now, are there common factors? And the answer is yes. T minus 4 and t minus 4 is a 1. So the answer for this will be 1 over t plus 2. Now, one of the reasons I suggested you put a 1 there and do it like this is that sometimes if that 1 is not there, students cancel this out and then all of a sudden put this up in the numerator. That's wrong. So this is the answer. Now, what are your restrictions? And the restrictions, and I'll give you a little shortcut way of doing it, just equal that to 0 and equal that to 0. So the restrictions are that t cannot be, and just transpose that, a negative 2, or t cannot be, transpose this, a positive 4. These are your restrictions. Keep in mind we can check our answers down below, and that looks good so far, and this looks good. Now we didn't write it in interval notation, we just wrote it in set builder, but they are saying or, so that indicates we can use either one. 2a is good, 2b, 2c, notice they have the 1 there, and our restrictions. Okay, we're going on to D and further. Going on now to letter D, we need to factor it. And the bottom. And we're looking for something divided by itself. So here this is going to be 2x and x. And this is going to be a 6 and a 1. And it looks like they're both going to be negative. So when I FOIL, it checks out. Okay, that's good. Now this one, x, x, 5 and 3, and this is going to be a Well, as I was looking at that, I saw that nothing looked like it was going to cancel out. But look up over here, and I didn't follow my own recipe. You're supposed to factor out any common factor. So when I failed to take out a 2 from each of these terms here, which would make this then x squared minus 4x plus 3, I ended up with factoring that. It factors okay, but notice in this parenthesis, I can still take out something. So from this parenthesis, I can take out a 2. That's the saving grace, so to speak, that you can catch yourself. So this will become a 1, and that becomes a 3. All right, let's do that. This becomes a 1, and this becomes a 3. Ah, now it's better. So this is going to be a plus, and this is going to be a minus. Now I have like terms. So now when I look for common factors, I have one here. These cancel out. So what am I left with as an answer? Well, you can go 2 times x minus 1 all over x plus 5. This is how they want you to leave the answer, in factored form. But what are your restrictions to the domain? Well, initially this was that and this. So here x cannot be, just transpose that, a3, or x cannot be, transpose that, a negative 5. And I kind of feel a little bad about this because I've said so often, check to see if there's a common factor. And I just didn't do it there. I was on a roll. Okay, let's go on, because now what we're doing is to multiply and, if possible, simplify. Let's raise this up a little bit. Gives us a little workspace down below. So I'm going to write these out so we have a little room. So again, you're looking for a strategy to simplify. So I just copied it down here. And you may have trouble to see where you can cross cancel or cancel out or factor out ones. So what I did is I took the 5 and I just wrote that. But the 18 I wrote as 9 times 2. 3 times 3 is 9. These are the factors of 18. And then 42 is 6 times 7. 2 times 3 is 6 times 7. And then 35 is 7 times 5. Now that I've laid it out like that, I can see I can cancel a 5 with this 5. 2 with a 2, a 3 with a 3, and a 7 with a 7. Ah. So what am I left with on the bottom? Well, in a sense, on the top, I have a 1 left there. And on the bottom, I have a 3. Okay. Now I have here y to the 6th and a 1y to the 1st, I should say. So this is on the bottom is going to be y, as I subtract that 1 from this, y to the 5th. And then x up here becomes minus 1. This will be x to the 4th. Now, we usually don't write the 1, so let's take that off. And then there is our answer. So from cross-canceling wherever we can, and you might say, isn't this too elaborate to do all this? Well, you do want to get the right answer. That's the key. And in getting the right answer, you need to copy things correctly too. So I had forgotten to put the 7 there. So I'm going to keep my 1 up there, and then I'm going to subtract 5 from 7 down here. So that gives me then in the denominator over here, x to the second. Okay. I couldn't see the forest for the trees there. I'm showing you a technique, and you need to copy it correctly. But it does get a little complicated. Now, you could have done it this way. 5 once, 5 goes into there 7 times. 6 goes into there 3 times. 6 goes into there 7 times. So the 7's then cancel out, and there's where your 3 comes from. And then you're subtracting a 1, giving you y to the 5th. You're subtracting the 5, giving you x to the second. So you could have done it this way. Again, I'm trying to show you what's going on. And again, the more you write, greater chances you might introduce an error, and you need to copy them correctly. Okay. Now for letter B, I should say, in which we have P's that are featured. So let's write these out here. And I'll try to be careful with it. P, that's pretty straightforward. Now as we look at this, this is the difference of perfect squares. This is going to factor into its conjugates. So P plus 1, P minus 1. And we have multiplication, and I can't take anything out of there. So just 2 sets of parentheses. And this is P, 3, 1. Okay, I did pause it to work on this a little bit up here. So this is factoring into P plus 1 and P minus 3. And my bottom here, I'm factoring out a P. And notice what I have here. I have a P that's positive and a 3 that's negative. And here I have a 3 that's positive and a P that's negative. I'd like this and this to be the same. Now in order to do that, I'm going to factor out from here a negative P. And that would make this positive. I'm sorry, that is positive. That would be negative. I've reversed the signs. So this then becomes negative and this becomes positive. So these, for all practical purposes now, are the same. Okay, now I look to see where can I cancel. Well, I have a P plus 1 here and a P plus 1 there. I have a P minus 3 and a P minus 3 there. Now, I have here a positive P and a negative P. So this is going to become this part here. I'll show it to you. P divided by negative P is going to be a negative 1. So up in the top here, I can put a -1, and on the bottom I have what's left, p minus 1. And let's see how they did it here as well. Now as I look down below, they have it this way, or they should have it this way. I don't see the negative sign there. Could have it this way or this way. Oh, I see. They just switched those around on the bottom, so that would be okay then. All right, so you could put the -1 there, or -1 over p minus 1. There's a couple of ways to do it, and hopefully your math lab should give you credit for that. That one was a little tricky. Okay, let's look at letter C now. And I'm going to take a moment to get that set up for you because it's going to take a little bit of time. Okay, just this one problem here took a long time. And let's see what we can do. So I factored this into 4 and n minus 2. Factored my denominator here into this numerator into that. Now here I see I can take out a 12n from each one, and that's what I have. Now I'm looking for ones. Well, I have an n minus 3 with an n minus 3, n minus 5 with an n minus 5. Now I have a 4 will go into there once, 4 will go into there 3 times. So on top over here, I'm left with an n minus 2. And on the bottom here, I'm left with a 3n, this 3n, and then n plus 2. And I was looking and I saw it was right there. Okay. Wow. Now, when we divide fractions, which is what we're doing here, we had said if you had 1/2 divided by 1/6, let's say, how did we do that? Well, we didn't cover that in this course, but from previous days of algebra or arithmetic, the rule was you take your first term, and that stays exactly the same, but then divided by this fraction, we change division to multiplication, and then take the reciprocal. We just flip the other thing, so we can cancel, and this becomes 3. 2 goes into there once, 2 goes into there 3 times. Okay? So in doing this division here, the only thing new would be to change this to multiplication and flip this. So rather than do it live, I'm going to do it and then look at it. All right, to do some of this live, I've taken this and factored it a little bit. Taken this, changed it to from division to multiplication, flipped this and factored that a little bit. So now I'm going to cancel out my 1s. So there's a 7 with a 7, a 4 with a 4, a 3 with a 3. And for the number part, I'm left with 2/3. And then here I can cancel out an A with a 1 here. This A with this other one here. And I'm left on the top with a to the 3rd. And then I believe I have a b to the 2nd left here. And let's see how we did. So that was 4a, 2/3. Yep, this is good. And again, what I'm trying to do here is show you how it's done. Change division to multiplication, flip this, and then do your canceling. And it's the same for letter B. A strategy might be initially to set it up. So I'm going to factor this, I'm going to factor that. These are conjugates. So it's A plus B, A minus B. And I'm going to, remember this is over 1, so I'm going to flip that. The 1 goes on top. So I have some factoring to do. Okay, like you, I had to check this out. I foiled it. I believe I have the correct factorization. And you might say, what is common that I could factor out? Well, this is an A plus B over A plus B is a 1. So what do I have then? Well, I have this times 1, and then I have 3 of these in the denominator. So I would write it like so, A minus B raised to the 3rd power, and this over this. Okay, that's where the answer came from. But again, these are taking time because each part of it is an individual problem from chapter 5. And we have to do each one correctly. But we want to know the procedure, change this from division to multiplication. Okay, now let's take a look at our asymptote that we have here. Now, here they're asking us to determine the vertical asymptotes of the graph. And basically, what that is to equate your denominator, and I'll show you this. Well, basically, to determine the vertical asymptotes, what you do is you factor your denominator. It's sort of like finding the domain. Here, each of these will be to 0, and this will be x equals a 1, x equals a 2, and these are values that would make your denominator a 0, but they also are your vertical asymptotes. X is 1, x is 2, right there. And the method to get them is to factor your denominator and see what you have. That would make our denominators a 0. Now, for this one, the numerator is the difference of perfect squares. And here the signs are reversed. If we take out a -1, this happens. These will cancel out. And now you don't have a variable in the denominator. So when there is no variable in the denominator, your vertical asymptote is none. I'm not sure how deeply they're going to get into this, but that's how it's done. And this was 34 minutes, so good luck with your practice and your quiz me. You need to really work on your factoring skills. Leave your answers in factored form.